Suspension and steering. The suspension system is a vital component in ensuring a vehicle's safety, comfort, and performance. It plays a key role in absorbing shocks from the road, maintaining tire contact with the road surface, and stabilizing the vehicle during turns and maneuvers. This lesson will introduce the fundamental components of suspension systems, such as springs, shock absorbers, and struts, and cover various types of suspension designs, including independent suspension, solid axle, and more. Understanding these elements is crucial for those preparing for the ASE certification test A4 and for performing real-world repairs and diagnostics on suspension systems. Components of the suspension system. The suspension system consists of several critical components that work together to absorb road shocks, improve handling, and maintain tire contact with the road surface. These components include springs, shock absorbers, and struts, each of which plays a unique role in the system. Springs. Function of springs. Springs absorb the shock and energy caused by bumps and uneven surfaces on the road. They support the vehicle's weight and allow for controlled movement of the wheels. Types of springs. Leaf springs. Traditionally used in older vehicles and heavy trucks, leaf springs consist of layers of metal that bend to absorb shock. They are particularly effective in supporting heavy loads. Coil springs. The most common type of spring in modern vehicles. Coil springs are wound into a spiral shape and compress or expand to absorb shocks. They are used in both front and rear suspension systems. Torsion bars. Torsion bars work by twisting to absorb shock. They are typically used in the front suspension of trucks and off-road vehicles. Air springs. Air springs are made of rubber and use compressed air to provide suspension. These are typically used in vehicles requiring adjustable ride height or in heavy-duty trucks. How springs work. When a wheel encounters a bump, the spring compresses to absorb the shock. Once the bump is passed, the spring returns to its original shape, helping the wheel stay in contact with the road. Shock absorbers. Function of shock absorbers. Shock absorbers help control the rebound of the springs, ensuring that the wheels stay in contact with the road surface. They convert the kinetic energy created by the springs into heat energy, which is dissipated. Types of shock absorbers. Hydraulic shock absorbers use oil to control movement. As the piston moves through the oil, the shock absorber converts the spring's kinetic energy into heat. Gas shock absorbers. Similar to hydraulic shock absorbers, but use nitrogen gas to pressurize the oil, reducing the chances of foam formation and offering improved performance. Monotube shock absorbers have a single tube for the oil and gas, offering better heat dissipation and consistency in performance. How shock absorbers work. Shock absorbers dampen the motion of the springs by controlling their rebound. Without shock absorbers, the springs would continue to bounce, making the ride unstable. Struts. Function of struts. A strut is a structural component of the suspension system that combines the function of a shock absorber with that of a spring. Struts are designed to support the weight of the vehicle and provide damping. Types of struts. Macpherson struts, the most common type used in modern front-wheel drive vehicles. The strut acts as the upper support for the coil spring and provides damping. Twin-tube struts. These are common in heavier-duty applications and provide more strength and durability. How struts work. Struts are typically used in Macpherson strut suspension systems, where the strut is mounted directly to the vehicle's body and serves as a structural element of the suspension. They provide both support and shock absorption, improving handling and ride quality. Types of suspension designs. There are various types of suspension systems, each with its advantages and applications. The main difference between suspension designs lies in how the wheels and axles are connected to the vehicle. Independent suspension. Definition. In an independent suspension system, each wheel is connected to the chassis independently, allowing each wheel to move up and down without affecting the other wheel. Advantages. Improved ride comfort, as each wheel can react to the road surface without affecting the opposite wheel. Better handling, particularly in turns, as the wheels can maintain better contact with the road. Common applications. Independent suspension is commonly used in front-wheel drive vehicles and modern passenger cars, where smooth handling and comfort are key priorities. Types of independent suspension. Double wishbone, a suspension design that uses two arms, wishbones, to control the motion of the wheel. It is often used in high-performance cars for better control of wheel alignment. Macpherson strut, a simpler independent suspension design using a strut assembly with a coil spring and shock absorber integrated into one unit. Multi-link suspension. This suspension uses multiple arms and links to control wheel movement. It provides excellent handling and comfort, often found in luxury cars. Solid axle suspension. Definition. In a solid axle suspension, both wheels on the same axle are connected by a solid beam, meaning when one wheel moves, the other moves as well. Advantages. Simple and robust design, making it ideal for heavy-duty vehicles. Better towing capacity and load-bearing ability due to the strength of the solid axle. Common applications. Solid axles are commonly found in rear-wheel drive vehicles, pickup trucks, and off-road vehicles, where durability and load-bearing capacity are crucial. Types of solid axle suspension. Leaf spring suspension. Often used in heavy-duty applications, this design uses a series of leaf springs to provide support and absorb shocks. Coil spring suspension. A more modern version of the solid axle, using coil springs instead of leaf springs to improve ride comfort. Torsion bar suspension. Definition. In a torsion bar suspension, the torsion bar acts as a spring, twisting as the vehicle encounters bumps and returning to its original position once the bump is passed. Advantages. Compact design that is used in off-road vehicles and some trucks. Adjustable ride height for specific applications. Common applications. Torsion bar suspensions are typically found in four-wheel drive vehicles, trucks, and military vehicles. Summary of suspension systems. Here's a table showing the summary of suspension systems and how they compare with each other. I'll give you a few minutes to review the table. Conclusion and recap. In this lesson, we covered the fundamentals of suspension systems, including the function and components of springs, shock absorbers, and struts. We also explored the various types of suspension designs, such as independent suspension and solid axle suspension, and discussed their applications in different vehicles. Understanding these concepts is critical for anyone preparing for the ASE certification test A4 and for performing suspension repairs in real-world automotive service tasks.